Hi everyone, so I'm here to share about my Lego Spike creation, which was an innovative version of the CNC machine. So you can do that in the broken is the lesson plan there, because when you put it together it originally doesn't work, so you have to make sure that can be fixed. And then the next thing I did was I actually changed the code so I can make it play Tic-Tac-Toe. And I added a color sensor so I could do that, so it could tell where I was playing. But otherwise, pretty much just the lesson plan and build plans from that CNC machine / broken lesson. So I'll talk a little bit about what I've liked about Spike Prime in comparison to the EV3s, and then I'll talk through the code. There'll be more documentation below, but it'll give you a good start, and then finally I'll do a demo. So as far as the Spike kits in comparison to the EV3, I've used both, and I've really liked the coding aspect and the interface of the Spike Prime a lot. I'm definitely anxious to try out the Python capabilities when Lego has that finished up. I think that'll be really awesome too, especially for students that are interested in being a little bit more advanced. But even just using the Scratch interface, I think it's a lot more similar to coding in other languages, and thinking about things like loops and functions and variables and lists. And I really like that component of it because I feel like it helps students kind of practice the thinking in those ways. Another thing that I really liked is just how convenient, as soon as you have your hub connected, so the hub is right here and is the actual brain of the robot. But as soon as you have it connected, you can actually see in the top left of my screen as like the color sensor changes. You can see if I move the motor, it changes the degrees of the motor. And it was actually really helpful for me in this project because then I could know where I wanted the motor to move to, and then just do the math by looking at what was the starting position and then what was the ending position. Okay, how many degrees does it need to go? It was super easy for me to be able to just keep referring to that and not having to go through any extra steps. So overall, like the Lego Spikes, my one complaint is that they're just so new that I had quite a few technical difficulties along the way for really no apparent reason. So when I would download the code, because this code gets to be a little bit bigger, something was going wrong somewhere and it wasn't telling me where. And even doing some pretty significant debugging and troubleshooting and just trying to find where the mistake was, it didn't seem like it was really tied to anything I was doing. It seemed like it was some sort of problem, either just in getting that large and complex of code onto the brick, or the hub, excuse me. I'm not sure what was going on there. But this ended up working. I'll show you kind of the main functions that we have going on here. So I have different variables that I used. So the first thing I do is initialize all those variables, set them to 0. For the Tic-Tac-Toe board, obviously it has 9 squares. So I set up each of those squares to have a variable associated with it. So A, B, C, D, there we go. A, B, C, D, E, F, G, H, I. If the robot plays there, it puts a 1, associates a 1 with that variable. If I play there, it associates a 2 with that variable. That way it can check for a win. It can check to see where people have already played and make sure to not play there. The other variables that I have are next play, so where the robot's planning on playing next. And then also the cat win, human win, robot win. If any of those turn to 1, that means that it's detected a win and that the game is over. So after that, I draw the board. Also pretty straightforward. It's just moving. We have two motors. One is right here. This is motor C. That controls some wheels that feed the paper, so that controls the vertical motion. And then this motor right here controls the horizontal motion of the pen. So by using both of those motors together, we're able to move the pen both vertically and horizontally. Technically, the pen isn't moving vertically, the paper is moving vertically, but it allows us to draw vertical lines. So then the next section, until there are 9 turns, so the turn count equals 9, that was another variable. We want to keep going through this loop. So the first, we're going to have the robot play. The robot just plays in a random spot. I think if I were working in Python rather than Scratch, I would probably spend a little bit more time making a smarter robot or a little bit more tricky of an opponent. But for now, the robot just plays in a random spot on the board. Next, it checks to see if either the robot or I have won. Then it waits for the player to go, so it moves the paper out of the way, or excuse me, moves the pen out of the way, so then I can draw in my play on the board. It waits for me to press the left button, and then it goes back to scanning the board, so it goes with the color sensor and looks in each of the 9 boxes, and then it checks to see if there's a win again. And then if there isn't a win, it'll just keep going back to the beginning, and the robot will play again. And the robot, when it's playing, that function is made up of it checking to see where there are empty squares, and then moving to whatever square it has found just randomly that it is empty. So like I said, I'll put more documentation about what each of those functions is doing in the comments. But now I'll do a quick demo so you can see how it works. Okay, here we have our setup. On the left, you'll be able to see the variables changing as we go, and on the right, you'll be able to see the robot moving. So those variables, A, B, C, D, E, F, G, H, I, all are associated with a square on the board. If the robot plays in the square, it'll turn to a 1. If I play in the square, it'll turn to a 2. Cat win, human win, and robot win are all just checking to see if either the robot or I have won, or if we have reached a tie. If any of those change to 1, that means yes, it has happened. And then you'll also see next play cycling through different numbers to make sure that no one has played in that spot. And if no one has played in the spot, it'll go play there for its next turn. Okay, so we will lower our pen and we'll be ready to start. There's our board, and it's going to play in that bottom middle square. Okay. And we can see now too that it has indeed played in H, so there's a 1 in H on that left-hand side. I'll play in the middle. The key is just to color it in enough so it doesn't need to recognize the color, but it needs to recognize that it's not just white paper. Okay, and then I'll hit left to tell it that I am done. And now it's going through to scan. One thing that you could do if you wanted would be to actually lift up the pen while it's scanning, so then it's not drawing on the board, but I just kind of leave it on there. So you can see these other lines over here just from scanning those artifacts, but it has played in this square, and you can see the actual circle in that square. So either way, if you want to lift it up, you can. Otherwise, you just got to be paying attention to where it's going. But you can see now too that it has recognized that I have played in E and it has played in F. So I'll go ahead and I'll play in this corner square next and press left. And it has found that I played an I, which is that corner, which is good. And now it played in this square right here. So F, I believe. So we'll play here. And we'll see if it detects a win. And there you go. It gave us a smiley face. And right now it'll just keep playing until it's to 9 turns. But you can stop it as soon as you see that smiley face. Okay, so there you have it. Like I said, I ran into some technical difficulties along the way. My best advice for that is to just keep trying to download the program. Sometimes I would the download would fail, and then the next time I ran it, even without changing any code, it would just go on there just fine. So I'm looking forward to future releases of the Scratch code, and then also looking forward to Python and hoping that I can add in a little bit more functionality on Python. I think it could be possible to do in Scratch, but I would lose a little bit more patience, I think, doing that. If you have any questions, feel free to comment. If you make your own version or any updates, I'd love to hear about them. And good luck and have fun.